Good afternoon. Welcome to our SK Technosium Math Group. I am DS Pravanjan of 6th test. I am going to talk about automatic compass. Let us see first what is a compass. A compass is a geometrical tool used to draw a perfect circle by placing a sharp point at the center and rotating a pencil around it. Using the compass manually is tough, so I made a robot called automatic compass. I made it with the simple things: 5V DC motor with the gearbox, a switch, a 5V battery holder with the batteries and a bottle cap, and ice cream stick and screw and a wire. The automatic compass is a device which draws the circle automatically without our manual intervention. I kept a name called Automac. First I took the battery holder's wire and I connected with the gearbox, and another wire with the switch, and I took an extra piece of wire. I connected with the gearbox and I switch, and I made a triangle shape in a ice cream stick, so I can stick this here in the ice cream stick, and I used the sketch to draw a circle, and this is the main grip of the circle on the middle, and this bottle cap is to rotate.
Good morning, I am Pragya and this is Saimitra. We are from 9th Standard Health section.
Today, we are going to see about an ellipse. An ellipse is a shape that is similar to a circle, but instead of one focus point, it has two focus points. These two are the focus points of an ellipse. So when we hit the carom coin from the ellipse, it enters the other focus point. This is a property of an ellipse. When something moves from one of the focus point and hits the border, it always returns to the other focus points. Here, a person can hear the whispers of a person even if they are miles apart, because when a person is standing in the elliptical dome and they are standing in the two focus points, when a person whispers, the sound waves hit the elliptical dome and they are reflects to the other focus point. So this person will be able to hear the whispers of this person.
There are so many whispering walls all around the world. Here are some of the famous ones.
The Gol Gumbas in Vijaypur, India, the Grand Central Terminal in New York City, USA, the St. Paul Cathedral in London, UK, and the Temple of Heaven in Beijing, China are some of the most famous whispering walls present all over the world.
Here you can see the model of Temple of Heaven. Here you have two focus points which, if one of the person whispers, the sound waves would enter to the another focus point by reflecting by the wall of the ellipse.
Myself Sri Lakshana.
I am Rashika.
Myself Dhanesh. Today we are going to explain about vector algebra using wind vane.
So, wind vane is a tool which shows the direction of the wind. It is also known as weather vane. How it works? A wind vane, usually shaped like an arrow, spins freely on a pole. When the wind blows, the vane rotates and points into the direction. The direction from which the wind blows is the wind direction.
There it is used. Wind vanes are used in weather stations. They are also used on small wind turbines to make the turbines pointed towards the wind. In olden days, these were often placed on the top of the barns and churches as a decorative architectural ornament.
The wind vanes are often shaped like cockerels, ships and horses. The traditional cockerel design is being used with letters to indicate the points on the compass. The word vane comes from the Old English word fana, which means a flag. So you may all wonder how Mach's principle is being used here, but you know that Mach is present everywhere. Yes, here we use vector algebra. So let me explain you what is vector algebra. Vector algebra is the branch of mathematics which deals with vectors, the mathematical object which have both magnitude and direction in it. The vectors are represented by directed lines and arrows in space.
Vector algebra plays a crucial role in understanding and analyzing the direction of the wind, commonly referred to as wind vane. The principles of vector algebra makes us describe and analyze how the wind's motion is represented mathematically.
Here is how vector algebra is used in the context of wind direction. Wind is a vector quantity. That means it has both direction and magnitude. So, the wind vector represents the direction from which the wind is coming and also the speed of the wind. Wind vane's role. Wind vane, typically mounted on a pivot, aligns itself with the wind direction. If the wind is coming from the north, the arrow will point to the north.
The wind's vector component and the wind vane's force exerted are all described and calculated using vector algebra.
In summary, vector algebra is essential in understanding and analyzing the wind's direction and speed, particularly with regard to how the wind vane responds to the wind's changes in wind's direction and its magnitude.
Thank you.
My name is Sharan B.
My name is Pravishwar.
My name is Sanjay. So here we are going to explain about a specific shape known as the parabolic shape. As you can see, what is this egg? What is the shape in this egg? Yes, it's an oval shape. But if I tilt this, you can see a arc shape, right? This is known as the parabolic arc. The use of this parabolic arc is to spread the power or the tension given to it all over equally. I am going to explain this using the egg experiment. See, I am keeping this egg in my palm and giving it equal pressure using my fingers. See, the egg is not breaking. This means this egg won't break, but it will break after giving a high pressure. So now we will explain it using the bridge.
I'm going to explain about parabolic bridges used in arches. Now we are keeping some weight on it, and what you observe from this, and this bridge is getting bent. Now we are keeping on with the same weight on its parabolic bridge.
Here we can see that it doesn't bend. It is because of these pillars and the parabolic arch. When the weight is added to this bridge, the pillars carry the weight to the parabolic arch and distribute equally to the ends of the bridges. Here we can see the different types of parabolic arcs used in the bridges. Here it is our main city, Chennai, Napier Bridge. Now I am going to explain another project known as the Napier Parabolic Reflector using this. Now this parabolic shaped mirror is placed and when parallel lines are passed through it, here you can see that the light rays pass through this point. This point is known as the focus point of this parabolic mirror. Here when we pass the light through the focus point, the reflected light always travel in the parallel line. So it's mostly used in vehicle headlights and etc.
Good morning everyone, I'm Santosh. So we're going to see what is integration. The word integrate meaning to join or sum up. In mathematical form, it is used to find the area under the curve. So we'll see how it works. Let's take a rectangle and place it under the curve and find the area. But still we will have some gaps left over it. So what we'll do is decrease the width and increase the number of rectangles. If we continue this process till infinite number of times, eventually we'll find the area under the curve. So my friend Sayan will explain the application.
So integration is used in many fields. So I'm going to cite some examples of it. In engineering, it is used to find the geometry of building, such as center of gravity. And in economics, it is used to find the firm's revenue. And in computer science, it is used to find any dimensions of object or a motion for realistic rendering. So integration plays a major role in physics. It helps us to calculate the position and the trajectories of an object in motion. So, for example, roller coaster and catapult. So, my teammate will explain about it.
So the first example here as they gave was catapult. So I have a small model of catapult. So we have an object here. I will be placing it here and shooting it from it. It fell on a point. So the distance between this point and this point, we'll have a curve. And to find the area between this curve, we'll be using integration. Our second example will be roller coaster. As you see here, here's a model of roller coaster. So I'll be playing it. So here we have two mathematical aspects here. One is trigonometry, the other is calculus. To find the height, we'll be using trigonometry here to find the height of this bars, and we'll be using calculus to find the accurate curves here, as you see. Yeah, thank you.